Do you think it would be good to start around 1:43? Is that enough time to make sure everybody's in?
I think we'll have to see. I'm cool with waiting for now until then, but yeah, it's just gonna depend. I know last I checked, I know the figures or how many people signed up or registered. Um, so yeah, I'll still wait a little bit longer, but we'll see.
Mm-hmm.
Oh, you guys like the background I found? This is cool, huh? Yeah, yeah.
I love how nobody agreed with you. You just
I
took that.
love how everyone's nodding and smiling
I was
except
like, yes, yes.
I agreed. I agreed.
I agree. Sorry.
yes, thank you. What are you doing? You could just come in regularly. Just, started, so. Okay. What are you doing? Anyway,
It is 1:43.
Okay.
So you want to wait like two more minutes, or do you want to start?
I'm fine starting. Oh, I thought I saw somebody else join. I might just be going crazy. Nathan, are we good to start? So, hello everybody. Thank you so much for coming, and welcome to Black Family
wait
Tech.
until 150, let's say.
150?
Or unless more people join before then.
Yeah.
See, 6th grade. So that's a cool grade.
I think 6th grade is the best year in middle school because you feel really cool about being in middle school.
I can't agree with that at all.
Like, what grade would you say is the best in middle school?
I think 7th because it's like right in the middle and you don't really
I
have
agree.
as far as like no pressure to be like, oh, you're going to high school, and it's no pressure like, oh, you're in a new environment.
But 6th so fun because you were meeting new people, you got to do new clubs, and everything felt new and exciting. And you're just like, yeah, I'm old now. I'm mature, responsible. Ooh, 8th grade is really fun too.
It's alright. Yeah. It's not bad. Better than 6th grade.
Incorrect.
I
Oh, 6th grade is still good too.
Yeah, I wasn't on board with the, oh wow, everything's new now.
So, does anybody have a favorite field of engineering? I know my favorite is biomedical engineering. Or any projects that you've been really interested? Or maybe even anything fun that you've done so far?
Yeah, I didn't know what engineering was, so off to a good start.
Ooh.
Ooh, brains.
So do you think that you'll do that, or I guess major in that when you hit college? Or are you just interested in it right now and you're still trying to figure out what you want to do?
Astronomy.
Astronomy is
I'm an
also
astronomer.
Astronomy.
That's a cool one. We're gonna get started in like a minute, let's say. But yeah, continue to share your fields and stuff. We're gonna go over the materials right here in the beginning. Um, I I don't know. Maybe you guys can answer that. But did you guys get like the materials like sent to you yet? Or I know Cynthia said some of them are still need to be delivered, I think.
Oh, Sophia for this. Yeah.
Yeah, for this one.
And we can probably see if we can send out this presentation after we're done today. So if you don't have the materials on hand, you can definitely do it on your own and have a really cool lava lamp.
Yeah, the all the present or hope I mean they're everyone's supposed to be recording their presentations for like each person's like classes. So I don't know where they will be found exactly, but I know they're being recorded so that kids can refer to them. So yeah, I think with that we'll hop right in to the presentation. Welcome to, well, Jasmine, do you want to do this or?
So, hello everybody, and welcome to Black Family Tech Awareness Day with Nesby. My name is Jasmine Williams, and if everybody else who's participating in this panel wants to say their names.
Hi, everyone. I'm Nancy Santi.
Hi, everyone. I'm Tahira.
Hi everyone, my name is Ichi.
Hi, Ichi.
Hi, my name is Sophia.
And if you're a little camera shy, you can always just type your name in the chat. We don't judge here.
I know, like, we could kind of see it, but I don't know. It shows you're here.
So if you haven't heard of NSBE before, we are the National Society of Black Engineers, and our mission is to increase the number of culturally responsible Black engineers who excel academically, succeed professionally, and positively impact the community. And today we'll be working with you on creating your own personal lava lamps. So if you can head over to the next slide. Uh, some of the things that we want to accomplish with you today is understanding chemical reactions and a little bit of about how they work, trying to learn and discuss how temperature has an impact on the chemical reactions that we will be doing today, disposing of certain ingredients because we're using some oils and you can't really dump them down the sink, and most importantly, creating your own lava lamps and having fun. And if you look at this brief video, you can see how lava lamps work and how some of them are made. And with that, you can take it.
This is so trippy. I could stare at this lava lamp.
Is that heard? First of all, alright, just want to double check.
Yes, we can hear it.
Yeah.
For hours. Wake up, Camry. What exactly is a lava lamp? Is this even lava? And how does the lamp create such mesmerizing floating blobs? To shed some light on this lamp, I brought on the help of an expert. There she is now.
Whoa, Ruby laughed far out.
Thanks. Are you my expert?
Yeah, I'm Asha J, a National Geographic explorer and a creative conservationist who knows her lava lamps. They're beautiful examples of how science blends with creativity. Now let's see your lamps. Hypnotic, aren't they?
Yeah. So, first question, am I actually looking at lava?
Nope. Lava is just a marketing name corporations give it. You're looking at two substances floating in harmony.
How exactly do they float in harmony?
To build a true lava lamp, your substances need to have different densities.
So one substance will sink to the bottom.
The other, and this is my favorite, immiscibility.
What's immiscibility?
It's a fancy science term meaning unmixable. The two substances in a lava lamp are typically water-based liquid and a waxy compound. They can never dissolve into each other. You can see it at home when you combine oil and vinegar. They never truly blend into each other.
Yet they taste great on a sandwich. All right, I see how two immiscible substances form the blobs in the lamp. But how do they rise up and down?
That comes from the power of your lamp's magic light bulb.
Magic light bulb?
Okay, it's a normal light bulb, but the heat from the bulb brings the magic. The heat causes the blobs of wax to rise. As they get further away from the bulb, they cool. Then they fall back down to the bulb, and the cycle begins all over again.
Why does the heat cause them to rise?
For that, we'd have to view the blobs on a molecular level, and there's no way we could possibly...
We could use my molecular shrink ray.
Yeah, we could do that. Honey, let's shrink us kids.
These must be the molecules of the lava lamp's blobs.
As the blob heats up, the molecules spread apart, lowering its density.
And a less dense blob will float towards the top.
Exactly. Now watch. See how the blob cools off? The molecules pack closer together? It's making the blob more dense.
It's amazing to look at a lava lamp from inside its own molecules.
Yes. Can we go home now? Camry. Camry. Camry!
Now that you know how that works.
Okay. So yeah, that was just a quick intro video. Just kind of explaining the science behind regular lava lamps, and it also hinted at what we're gonna be doing with the oil and water. So we're gonna jump into the materials, and again, these are all the materials we'll need. I don't know if we all have them, if you all have them. So the Alka-Seltzer tablets, vegetable oil, water, food coloring, a mason jar, and measuring cups to measure the ingredients, and access to a fridge or freezer or like really hot water. So either or you can choose. So yeah, do people, and feel free to either type it or say it out loud, but do you guys have the ingredients yet, or not yet? I see. Okay. One person said no. Another person said not all of them. Um, you kind of. Okay, no. Is there anyone that does have them then? Because I'm noticing it seems not all of you, not a lot of you do. Does anyone have them? Like all of them? It's okay if you don't, because again, this is going to be recorded, and you guys will be able to access all of this and kind of do it on your own. And it is really cool. I do encourage you to come back once you do get all the materials sent to you, um, and definitely play around with this. But so we're gonna run. You don't have a mason jar. Okay. Um, I mean, you don't need a mason jar exactly. Then you could use a like a just something transparent, like either a bottle or a like a glass. I want to say wine glass. I don't know if that's I don't really know if that's allowed. But yeah. So do you would you want to find a substitute, or you just kind of want to follow along and do it later?
Maybe we'll work in a water bottle. It might be a little harder pouring everything in, but it's still transparent and you can still close it if you have that.
Yeah, a water bottle would also work as long as it's like average size or even big. Um, if you again, don't worry if you don't have it, because again, you'll be able to come back to this. You have water. Okay, so that would also work. If you want to use that. And for those who don't have the materials, still you can follow along and kind of uh, absorb all the stuff, so you can just do it on your own when you do have the materials. So those are the materials, and I just want to note that for this and for this workshop, it might be better to move to like your kitchen or your dining room or something. Just like maybe stay away from other electronics, just in case something might happen and spill or knock it over or something. That'd be really bad. So if you want to take the time to move somewhere else, you can, considering not a lot of us have the materials. I don't think that's really relevant right now. But when you do have it and you want to run it, make sure you're running it away from any high risk items. Um, and another note, when you are pouring it, whenever that may be, pouring the ingredients, when you're done, make sure to screw the lid, and this applies obviously for a mason jar or a bottle, but make sure you screw the lid on tightly after you're finished adding things, just so that again, we avoid any spills or accidents. So with that, we're gonna hop into the actual experiment that you can run. Um, if a part is unclear at all, just let me know and I'll go back to it. So the very first step you want to do with your jar or bottle, you want to fill it with 1/4 cup of water. It could be room temperature, cold, hot, whichever. Just water. And then after you add the water, you want to add 3 drops, or really, I find that it works better with like the least, not the least amount of coloring, but like you don't want to do too much coloring. Um, so just three drops or whatever you feel like you want to do of food coloring, and you can choose a color, obviously. Do a color you really like. Um, and after you add the food coloring, you can add 1.5 cups of vegetable oil. Um, it is a decent amount. Uh, yeah, we were just we're gonna be making our own cool lava lamps. So we're just running through the experiment. Again, this is going to be recorded, so you can refer to it later if you miss any parts or you just want to review something. But these are very quickly the materials we need. Nyla, do you have the materials sent to you already, or are they not there yet? You can say it or write it in the chat. Okay. Um, yeah. I was just asking if you already have like the materials on this slide, because I know all of you that are signed up for this should be getting it sent to you either already or in the future. Thank you, Jasmine. Jasmine posted the list of materials, so you guys can look back at it, even if I go forward in the slides. But yeah, you'll need those materials to run this experiment. So don't worry if you don't have it yet. I know it should be getting sent to you in the near future, and you will have this recorded to work with. So going back to the experiment, you're gonna add your water and your food coloring, and then the 1.5 cups of vegetable oil. And then after you add all these liquids, you want to decide if you want to make your jar or bottle cold or hot for the experiment. So if you're doing cold, you want to put it, that means you have access to a fridge or freezer. You want to put the jar or bottle into the fridge or freezer. Either one works, and it's going to be for 5 minutes. So you just want to time that however you can. And then if you want to do hot, you put your jar or bottle, and it might be kind of hard depending. Oh. Hello, Dafina. We are just running through the experiment for your own lava lamps. Emergency tablets. I don't know. The thing is, I haven't tried this experiment with a lot of different tablets. I tried it with a different type of Alka-Seltzer, and it didn't work at all. So then I got the Alka-Seltzer plus cold, and that worked. So I think it might be very like finicky depending on the tablet. So I would say try to get that exact one, if you can. If you don't, then I just want to say that there might be a risk that doesn't actually react how we want it to. So I would preface with that, and yeah, so try to get that exact one, just so you know we're not you aren't disappointed if it doesn't the chemical reaction doesn't happen. So yes, we're on step 4. After you add, if you go through steps 1 to 3 of the liquids, you can decide if you want to make your jar or bottle cold or hot, and follow each thing for whichever type of bottle you want. For the hot, it might be a little harder depending on if you have access to a bowl big enough or pot, and how your bottle or jar is. So I would say if you kind of want it easier, you could just go with the cold option and stick it in the fridge or freezer. But it is cool. It is. You'll see later, but it is also cool when it's hot. So you can just, another option is to run it under hot water, or keep it running under hot water. So yeah, you have a lot of options for how you what you want to do with your jar. But after you do step 4, you can go to step 5, which is take one of the Alka-Seltzer tablets, the Alka-Seltzer plus cold, that you should be getting sent to you, if not already. Break one of the not pills, but the tablets into pieces, and you can do that with your hands. I did it fairly easy to do. If you are struggling, maybe get a knife if you feel comfortable with that. But yeah, you shouldn't really need that. And you break it into pieces and then break the pieces over the jar or bottle, and just watch it drop in there and start your timer. You probably had a timer for step 4. So you can start your timer for this step and watch the pieces fall into the bottle or jar. and then watch the reaction and watch what happens. After that, you can stop your timer. Basically, you should judge it when there's not a lot of new bubbles being created, formed, and you'll see what I'm talking about when you're doing it. So yeah, you should time it and try to stop it when it's done, and that is the experiment for your lava lamps. Does anyone have any questions about the steps and how they might, maybe they need clarification for a certain step or something before I move on? If something does come up to you later, feel free to type it in the chat or something, and we'll definitely get to it. And moving on to the reflections for after you run the experiment. So it's, I know I'm gonna hand it off to you, Tara, but I know that not a lot of you have run it or have seen it. So I'm thinking, would it be a good idea to play the ending video?
Yeah, I was just about to ask.
Okay. Yeah, so this is gonna be, this is how it can look. Oh, and I think Jasmine's putting the steps in there in the chat. But yeah, so this video is gonna show you how it Oh wait, what was your question? What was your question? Whoever asked that, I didn't see it. You can also talk too. It might be quicker than just typing it, but whichever you're comfortable with.
Maribel asks, can you use the ingredients over again?
You can as far as like using the like what you have in the bottle and then dropping another tablet, or what specifically? Because you can definitely, like, once you have your liquids, you can definitely just keep dropping tablets in there, and it'll still, like, the chemical reaction will still happen. Yeah, so that's why yeah. So actually, one of the reflection questions has you dropping another tablet in there, or basically dropping another tablet in there. So yeah, once you have it, and again, it's like it's your own lava lamp, you know. So once you randomly want to see that reaction, you just drop a tablet in there, and yeah, so you can definitely reuse it. We're gonna show a video about how it would look, just because it'd be better to answer the questions. Yeah, it just kind of goes on like that. So that's how it would approximately look. If you were running it on your own, running the experiment on your own. So we're gonna, if anyone wants me to replay the video again, to see it more, just let me know. But yeah, so these are the reflections, the reflection part.
So the first reflection question is, what happened when you dropped the Alka-Seltzer into the jars? If you want to type in the chat, you can say it out loud, or if you watched the video and saw what happened, Nyla said it fizzled. Yes. If you did the experiment, did you hear like any bubble noises? Any little She agrees. Okay, yes, we love participation. The bubbles rose from the bottom and it had a chemical reaction. Yes. So as the tablets dissolve, there's two things inside of the Alka-Seltzer tablets that make this reaction happen. It has sodium bicarbonate, which is baking soda, and then it has the citric acid, which has hydrogen on it. So when it dissolves into the water, you have the sodium part and the bicarbonate part, they split apart. And so the bicarbonate is going to react with the hydrogen to make carbon dioxide, which is gas that you just like breathe out, but also all those bubbles that were in there, and it makes water also. So that is the chemical reaction that's happening. And the next question is, how did your reaction look in hot water versus cold water if you did different temperatures? More bubbles, less bubbles?
It might be, I know, yeah, one person, I know a lot of you don't have the materials, so you didn't actually run the experiment. I think one person does have the materials. Correct me if I'm wrong. So, are you running it alongside with us, or are you gonna wait? Um, so yeah, I was gonna say that considering you didn't actually run the experiment, you guys can just like guess if you can give your best guess with some of these questions.
Also, Sophia, did you use hot or cold water? Okay, cold water. Nathan, can you go to the next question? Oh, you have a prediction. Hot should bubble. So this kind of goes into the next question, which is how long did the reaction take and what impact do you think the temperature had on it? So do you think that, or did you see that the hot or cold was going to go faster? Do you think that hot should be faster than cold? Cold should be faster than hot? And you can take guesses if you don't know, because that's okay.
I think Maribel said that the hot should bubble more.
Okay, Defina said hot would go faster. Ichi said hot may be faster. Maribel said hot would be faster. So great guesses.
We have a lot. We have chemical engineers in the building.
That's me. I get to explain this all the time. So, fun fact, science fact, chemistry fact. If a reaction is hotter, it's going to go quicker. So, the molecules will move faster at higher temperatures. So that means they have more of a chance to kind of bump into each other as they're reacting. And molecules have to bump into each other so they react and make a new thing. So if they're hot and they're all bouncing around really fast, that means they're going to crash into each other faster, and then there's going to be more bubbles and the reaction's going to go quicker. If it's colder, the reaction is kind of like, oh, I don't really feel like reacting, like I'm fine where I am. So the bubbles, the molecules like sodium bicarbonate, they're not going to separate as quickly as they would in the hot water. So that means the reaction is going to go slower since they're kind of moving slowly. They don't want to bump into each other that much, and it'll just take longer. which might mean you have more bubbles, but they'll just be slowly over time. But the fast one, the bubbles might be gone quicker. So does that make sense to everyone? Do we need a different explanation? I can explain it again. Okay.
Yeah, so actually, okay, just super quickly, if you run it on your own, for if it's a hot quote unquote chemical reaction that you're doing, the entire thing will happen in like less than a minute. It'll be super fast and cool looking, but it'll go out really quickly compared to if you're doing it cold. That is something to look out for.
And the next question is, why do you think the gas bubbles moved up and down and not like side to side, like in the video? Why did they move only up and down?
That's a pretty good question. I wonder who asked that, who wrote that in there.
And if you don't know, you can guess. Okay, yes, Nyla, it does go in a type of cycle. Gravity. Gravity is also part of this. The only way is up for air. That is true. That's correct. So, yeah, Nathan, you can load the answers. So, lots of things. Gravity, the cycling, and the fact that air has to move up. So, gas bubbles, which are those carbon dioxide bubbles that were in there. Yes, Defina, gas rises. The gas bubbles that were in there, which are from the carbon dioxide, those are kind of being formed in the water, but gases just really want to escape and go everywhere else, except for stay in one spot. So when they're all bubbling and they're in the liquid, they just want to float up because they're lighter than the water. So they take up less space, but they just want to leave. So they'll go up. And then it's bringing like the food coloring and whatever was around that bubble with it. So when the bubble goes up to the top, it's gonna pop into the rest of the air up there, and then the food coloring and whatever else was there is gonna kind of flow back down into the water at the bottom. And that's just gonna keep going until all of the tablet is dissolved. And then, oh yeah, I just said that. So cool. And then next question is, what are the differences and similarities between the real lava lamps, like the one in the background on the slide, and our Alka-Seltzer lava lamps? And if you forgot in the beginning, the video that we watched had real lava lamps. They have like a light bulb at the bottom that gets really hot. And that's what makes the real lava lamps look like that. So what's different and similar between those? The bubbles in the real one are bigger, yes. That is true. Real lava lamps have bigger bubbles and they go up slower. I forgot what they said was in the real lava lamps. Is it just oil and
It's
water?
in the real ones, it's water, like a sort of like basically water liquid, and then the bubbles are actually like a wax type of deal.
Oh, okay, that makes sense. Okay, Nyla said it's a bigger bottle. Yes. Real lava lamps use light bulbs, have larger bubbles, and both are different colors and different chemicals. Those are all true. Very good guesses. Last longer, says Defina. The real lava lamp or the Alka-Seltzer one?
Yeah, the real one.
So the answers, you guys are all have great answers. So the real lava lamp is relying on the heat to make the lava go up and down. So technically, it does last longer. Like if you keep it plugged in for a really long time. I used to have a lava lamp in my room, and I wasn't allowed to leave it on at night because it got really hot. So if you leave it on, if you leave it plugged in the whole time, you're just gonna have bubbles like going for as long as you leave it plugged in. But with the Alka-Seltzer tablets, those are like maybe this small, and they're gonna run out. So when that's gone, the reaction's done. So, and the other thing about the real lava lamps is that they rely on heat for the bubbles. So hot, that's not true. Well, hot things are going to have more bubbles if we're making bubbles. So if it's hot, the bubbles are going to go up. But those aren't made from like the same thing as carbon dioxide going up. So there's a different kind of situation happening there. But that's why they're different. And there are different molecules in there. Nathan said it's like the wax thing is what's making the bubbles. So that's probably why they're a lot bigger than the oil and water kind of bubbles in your Alka-Seltzer bottles, lava lamps.
Yeah, the wax is. That's why it kind of looks like it has the whole like cool gooey kind of effect, because that's how the wax is sort of not reacting, but like in the lava lamp compared to ours, which is just, it's gas, so that they are at their core different.
And then the last question is, what do you think would happen if you use a whole tablet versus breaking the tablet into little pieces and then putting it into the water and oil mixture?
Kind of as a hint, the video we showed, the person only dropped like the one tablet and then let it do its thing. When our experiment directions were to break it up into pieces, so you can kind of see and compare like that.
The heat would make it faster. You have smaller bubbles, reaction wouldn't be as strong. Pieces make smaller bubbles. Yeah, it wouldn't last long. So you can load the answer to this one, please. So the more broken up the pieces are, the more spread out the reaction is. There's a side note from this, there's something called like surface area. So the more spots there are on the Alka-Seltzer tablet for the water and oil to kind of touch it, that means there's going to be more reaction. It might be faster and go by quickly, but it's all going to react a lot faster than one big tablet spot. So it's more spread out. There'll probably be more bubbles, but it might not last that long. But you can still try at the end if you want to, or when you get your supplies in, you can see the difference between those. But great participation. We love it.
Yeah, and just to again, if you maybe go back and you want to like observe it for yourself, but in the video that we showed, dropping the one tablet, it was kind of like as a streak, or like a vertical sort of like a vertical line of like the carbon dioxide, the gases, right? The gas rising and the bubbles. Whereas if you run it on your own, or in our experiment on your own, you'll see that it's a lot more like spread out across the whole bottle. So. Now we're going to talk about how to dispose of it with Nancy.
Okay, just going to talk a little bit about how to properly dispose after you finish your lab experiment and the materials. Okay, so first question is, what do you think happens when you pour oil down the drain of your sink?
And it could be like any oil, vegetable oil, vegetable olive.
Canola.
Yeah.
Yeah. Okay, now let's add will stain. Good, Maribel, it won't mix with water. Nyla. Am I saying it right? Nyla.
Yeah.
Okay, so sorry. Okay, perfect. Depends on the type of water system. Okay. Nina said it will make grease. Okay. Okay. It will stick, Sophia said. Okay, perfect. All good answers. Okay, and here we have, so oil, especially when it's mixed with different other ingredients, it can harden into soil over time and it causes drain to clog up. So like how you said, it'll stick, it will like affect the water system and it won't mix with the water properly. Okay, next. Okay, and so whenever you want to empty your lava lamp after you finish the experiment, or you just want to maybe make another one, you make sure that you put it outside away from any plants or trees so that it does not affect them as well. I mean, it's best if you dig a hole outside and pour it down there, but this is just ideal. You don't necessarily have to necessarily go to those plants and make a hole and to pour everything down there. But if you can't, it's okay, but that's just most ideal way to get rid of your things. Okay, and I just want to talk a little bit more about what we already discussed about the proper way to dispose. And the reason that we want to make sure we dispose properly is that when you use your drink to dispose of used cooking oil, the oil creates these fatty blobs of soap, and which makes it a really sticky mess when it's all through your sink. And so as it travels down your sink pipes, it makes its way down to the sewer with the other waterway systems in your area. And so where it mixes with all that other wastewater, it causes damage to your pipes. So which is a problem for proper water flow, for even renovations, things such as that. And yeah, overall damages the pipes and buildings, and we certainly don't want that. So just be sure that you dispose everything properly to get away from all that sticky mess that we don't want. Any questions on that? We can watch the video again if we want to.
Do you guys want to? We could play. It's what, like a minute? Yeah, it's a minute 30. If you just want to see the reaction again after we've gone through some of these like reflection questions, let me know. Okay, cool. Also, I just want to point out that you can see how it's falling back down afterwards, so it's pretty cool. And again, your jars or bottles are reusable in a sense. So like, once you have all the mixture and whenever you want to drop Alka-Seltzer tablet in there, you can, and it'll work the same way. Well, not the exact same, depends on the temperature and stuff. Jasmine had a good point in the chat.
Okay, and that's it. Thank you so much, everyone, for participating and coming to this. Feel free to, of course, like we said, add more pieces of Alka-Seltzer tablets to your lava lamp, and like Jasmine said, feel free to experiment as well. If you have a flashlight, definitely try to create that effect of like the actual lava lamp on top of the flashlight in your dark room. Then you can also try making your jar hot or cold, depending on what you want to use first, and just seeing the difference between those two. And yeah, that's it. And feel free to ask us any questions you have. Feel free to say it out loud or put it in the chat.
I'm sorry that the materials didn't get sent in enough time, but I hope that when you actually do get the materials, you're able to have fun and actually create your own lava lamps.
Yeah, it is really cool, and it's like quick too. No, that's totally okay. as
Yeah, no problem.
Thanks for coming, everyone.
Thank you.